All right, everybody. Hope all is well. So we're going to start with number one. This worksheet is going to be focusing on the solar system mock Regents review. And number one, it says, in our solar system, the orbits of the planets are best described as what? All right. The orbits of the planets and focusing on the shape. And so in the options, I already see right off the bat, I see either circular, right, or elliptical. So if we look at our notes, oops, sorry. If we look at our notes, one of the things that we can see right away is that is Kepler's first law, right? That planets do not have perfectly circular orbits. Planets do not have perfectly circular orbits. As a matter of fact, all planets go around the sun in an ellipse with the sun at one focus of the ellipse, okay? And so this rule follows for any object that is orbiting another object in space, right? Whether it's the moon that is orbiting the Earth, the shape is still an elliptical orbit, not a perfect circle. And there are two focus points, and one of the focus points has to be whatever the object is orbiting, right? So if the moon is orbiting the Earth, then the Earth is in one of the focus points. And so in this question right here, what are all of the planets orbiting, right? All of the planets here are orbiting the sun. All the planets are revolving around the sun. So that means that it has to be an elliptical orbit, right? It has to be elliptical orbit, so it definitely can't be circular. And it has to be with the sun at one of the foci, because all the planets are orbiting around the sun. So if a comet is orbiting around the sun, then that means that the sun is at one of the focus points. So the correct answer is choice B. All right, number two says, base your answers to the following question on the Earth science reference tables and the diagram below. The diagram represents the orbits of three planets X, Y, and Z around star A. Star A is located at one focus point and point B is the other focus point. Numbers 1 through 9 represent different positions of the three planets. The arrows show the direction of revolution. All right. So it says, which statement about the period of revolution of the planets is correct? All right. So when we talk about the period of revolution, we are talking about how long does it take? How long does it take for that planet to go around the sun? All right. The period of revolution is how long does it take for the planet to go around the star, right? And we want to know which statement is true. And so the rule for the planet, for the period of revolution, right? The rule states as follow, and I'm going to type this as well too. Let me make sure. All right. And here, this is the rule, right? The longer the period of revolution, right? The farther the distance the planet is from the star. All right. So that means if you have a planet that's very close to a star, it's going to have a very short period of revolution. All right. So that's something that we are going to keep in mind. Right. Oh, there we go. Let me move that right here. So it says which statement is correct. So let's take a look. Planet Y has a longer period than planet Z. Let me just look up. All right. Oops. Here we go. All right. Planet Y has a longer period of revolution than planet Z. That is incorrect, right? Because planet Y is not farther from the star than planet Z, right? Planet Z has a longer period of revolution than planet X. Well, is planet Z farther from star A? Yes, it is, right? If we take a look, planet X, distance to the star, I measured in pink, and planet Z, distance from the star, is in red, all right? And one of the things that we see, and I'll draw it again, one of the things that I see, planet Z is definitely farther from the star than planet X. So that means that it does have a longer period of revolution than planet X. All right, based on the rule that we just stated right here, right? How long does it take? Ooh, I'll put it right here. How long does it, the longer the period of revolution, the farther the distance the planet is from that star. So B is the correct answer. All right. So number 3, it says circle the options that directly links with the impacts of large asteroids on Earth are inferred to be associated with the following. All right. So which of these statements directly links to the impact that large asteroids have on the Earth? Okay. So definitely number 1 is the fact that there was large global climatic changes, right? So that was one thing that the large asteroids on Earth, the impact that it had, right? Large global climatic changes. The other thing, because of that, right? The other thing, because of large asteroids that come into contact with the Earth's surface, the other impact that it has is the extinction of dinosaurs as well, too. All right. So these two statements are correct. And so that's just something that you do have to know to memorize as part of your notes. All right, number 4, which factors cause the interior layering of Earth's and other formations in our solar system during their formation, right? So one of the things you have to know, right? We know the crust, the mantle, the outer core, the inner core, right? They contain different materials. And these different materials have these different materials, right? They have different densities. They have different densities, right? Sorry, yeah. So that's one of the factors of why it's layered, why the interior of the Earth is layered this way. It's because of the fact of density. Because all of these materials contain materials that have different densities. And what do I also notice, right? That the materials that are the densest, right, they would sink to the center. Materials that are the least dense would be more on top or on the surface. And the other impact, the force that leads that is also gravity, right? So we know that the inner core has the most densest materials. The inner core has the most densest materials. And how do I know that? The inner core is in the center, right? And the force that it's allowing these materials to get pulled down to the center is gravity. So your two factors are density and gravity. And this plays a role with all of the other planets in our solar system. They're layered that way just because of density and gravity. All right, number 5 says, identify the scientific device that is used on Earth to prove that Earth rotates. Key word, that Earth rotates on its axis, right? So we have this pendulum that swings back and forth, and to us, it appears to change direction, right? It appears to change direction as it's swinging back and forth. And so what is this device called, everybody? This device is called the Foucault pendulum. All right, this is an important device that provides evidence that the Earth rotates. Something to keep in mind. All right, number 6. All right, so it says base your answers to questions 6 through 8 on the information data table and diagram below. So they're telling you all this information below is going to help us in some way in shape or form for numbers 6 through 8. All right, and so it says astronomers have discovered strong evidence for the existence of 3 large extrasolar outside the solar system planets that orbit Upsilon Andromeda, a star located 44 light years from Earth. Okay, so it is a star. That's one thing to keep in mind. The 3 planets are called Planet B, Planet C, and Planet D. Some of the information gathered about these 3 new planets is shown in the table below. The period of revolution for Planet C has been deliberately left blank. The diagram below compares a part of our solar system to the Upsilon Andromeda. I know I'm probably pronouncing it wrong. Planetary system. Planet distances from their respective star and the relative size of each planet are drawn to scale. All right, and so we have the chart here. And let's take a look. So question 6 says, as planet B travels in orbit, describe the change in orbital velocity of planet B as the distance between Upsilon Andromeda and planet B decrease. All right. As the distance between planet B and the star Upsilon, right? What happens to the orbital velocity as the distance between planet B and star Upsilon decreases? Okay. So what do I know? Here's what I do know. I know, oh, there you go. I know that the closer a planet is to a star, the faster the planet travels, right? This is one of Kepler's 3 laws, right? Regarding planetary motion. All right. So because of the fact as planet B gets closer to the star, right? The distance decreases, right? That means that gravity has a stronger effect, right? As it gets closer, right? So as it's orbiting the star, all right, as it's getting closer to the star, there's a stronger pull that's occurring at planet B. So because of that, we know that the orbital velocity, right, the speed of the planet is going to increase just because of what we said. The closer a planet is to a star, the faster the planet will travel. And so therefore, your answer has to consist of what is shown on the screen. As the distance between them decreases, the orbital velocity increases, right? The planet will speed up. So that's something to just keep in mind, right? Any of these options would be fine. All right, number 7. Number 7 says, if our solar system had a planet located the same distance from the sun as planet C is from Epsilon Andromeda, what would be its approximate period of revolution, right? So when I'm looking at this chart, they want to know if we had a planet right here, right? Because planet C is located right here, right? And they want to know if we had a planet that was located right here, right? What would be its approximate period of revolution? Remember, we said the period of revolution is how long does it take for the planet to go around its star, right? How long does it take for the planet to go around this star? So, for example, the Earth takes 365 days, right, to go around, to orbit or revolve around the sun. That is the Earth's period of revolution. So we need to know if planet C was right here, what would be planet C period of revolution? So what are the two planets that I see? I see Venus and I see Earth. So that means that I definitely need to pick a number, right? that is between Venus' period of revolution and the Earth's period of revolution. What page of the reference tables do I find that? I'm going to page 15, as it's highlighted right here, right? The period of revolution for Venus, as we see right here, is 224.7 days, and the Earth is 365.26 days. So therefore, planet C has to be a number between these two. Why is that the case? Because they're talking about it right here. They want to know what would be planet C period of rotation if it was located right here between Venus and Earth. So if you said any answer that is greater than 224.7 days, right? Any answer that is bigger than Venus period of revolution, and any answer that is less than Earth's period of revolution, you are correct. So if you said 260 days, you're correct. If you said 300 days, you are correct. They're asking for just one number, not a range, right? They're just asking for one number. So if you said any answer that is between 224.7 days, right, to 365.2 days, you are correct. It has to be in between these two numbers. In between, not including these days, right? So if you said 260 days, that's fine. If you said 300 days, that's fine. If you said 330 days, that's fine. As long as it is a number in between 224.7 days and 365.26 days. All right, number 8. Number 8 says planet D's diameter is 10 times greater than Earth's diameter. What planet in our solar system has a diameter closest in size to the diameter of planet D? So they're telling us planet D's diameter is 10 times greater than the Earth's diameter. Well, where am I going to find out what the Earth's diameter is, right? And the diameter is talking about how wide the Earth is, right? How wide the Earth is. That is what the Earth's diameter is. That is what the diameter is. So when I take a look, I'm looking at page 15 of the reference tables, right? The solar system data chart. And when I'm looking, I see equatorial diameter right here, and I'm going to look at Earth's, right? And Earth has a diameter of 12,756 kilometers. So the question is saying planet D is 10 times that amount. So 12,756 times 10 gives me 127,756 kilometers. All right. Now, which planet has a diameter that is closest? That is closest to 127,756 kilometers. Which planet is closest to that, right? Because this is planet's D. This is planet's D diameter, right? And when I'm looking in this column, the one that's closest to this number is right here. Right here. And what planet is that? Saturn. So the correct answer for number 8 is Saturn. That is the correct answer for number 8, Saturn, right? 127,000 is closest to 120,000 right here. That's the closest. All right. All right. Number 9. Number 9 says, base your answers to the following question on the diagram below on your knowledge of Earth science. The diagram represents the moon's orbit around the Earth. State the average distance between the sun and the Mars. Include units with your answer. So clearly there's some typos, right? This diagram has nothing to do with the question. So there is a typo. I apologize for that. All right, so it says state the average distance between the sun and Mars, right? Include units with your answer. So that means we have to include units in our answer. We're just not going to write a number, right? But we have to cover it with a unit. So I'm going to go to my favorite page of the reference tables, page 15. I'm looking at solar system data, and they're asking for the average distance between Mars and the sun. So I'm going to go to mean distance, right? Because the word mean means average. All right. And the reason why it's average is because as a planet goes around the sun, right, the planet does not revolve around the sun in a perfect circle. So that means the distance between the planet and the sun will change as it's revolving around the sun. So I see 227.9, right? Now, if I just write 227.9, that is going to be incorrect. Why? Because they tell you that it's in millions kilometers. So that means my answer is going to be, 227.9 million kilometers. That is the correct answer. If you just wrote 227.9, it would be incorrect. If a question says to include units, make sure to include units. And anytime you're pulling any number from the reference table, they're going to give you the units with it. All right, so that's something to keep in mind. That is the end of this video. Have a wonderful, blessed day. Until next time, make sure to like, share, and subscribe. Take care, everybody.